Hello there. I just wanted to do a video regarding the Digitrax SE8C and the use of 4-aspect signals in the UK. Now in the UK we have 4 aspects being red, a single amber, a double amber and then green. Even though the Digitrax literature says you can have a 4-aspect signal, it's a little bit of a con, because they treat the 4th aspect as the 3rd lamp as changing to flashing amber, and they call that the 4th aspect. Well, that doesn't fit with us in the UK. I mean, yes, we do use a flashing amber, but that's under junction control normally on high-speed lines. So I've been trying to work out how I could get the Digitrax board to operate 4 aspects as we do in the UK without using another switch, because you've basically got 2 switches for each mast head. Now what I've used the supplied Digitrax LEDs with the bottom one red, a single amber, a green, and then I'm actually going to demonstrate just using the middle amber of the top lamp to represent the 4 aspects as we've got in the UK. I'll just come across to the circuit diagram that I've drawn, and the way that I've got this to work is to use the auxiliary outputs that are supplied on the board that are not documented because they don't use it. This is for future use, but the auxiliaries, they actually produce a constant negative voltage which we can use to our advantage. Now the board, as I understand it, to get so many LEDs working from effectively the 8 wires, or the 10 wires if you include the commons, it uses a technique called Charlie plexing. Now that does come with its own problems, because if you then use a common positive and a common negative to run your chips, it doesn't work properly. You have to have the positive and negative of each chip being switched on and switched off in the same sequence as your LEDs. Now Charlie plexing basically switches the common on and off very quickly, but it's not noticeable to the human eye. Anyway, just Google Charlie plexing and you'll find some videos on how that works. But what I've managed to do is using a Nand Gate, which is a 7400 chip. I'm looking at the red and the green, and basically what I'm saying is when the red and the green go out, i.e. go high, it produces a low output, so there'll be a 0 volts here, and because I'm tying it to the common high, electricity will flow, lighting up my amber LED, and I want that to create a single amber. In the manual, the option switches, I think it's option 9 and option 10, tell the machine what to do with the 4th aspect, whether you want it to be flashing amber or flashing dark. So flashing dark, to go dark. So I've set mine to be off. So you've got the amber switch will either be a single amber, and when it's where is it when it's thrown, when it's closed, beg your pardon, effectively the amber light's going to be off. When it's thrown, the amber light comes on. I'll show you in a second, but anyway, here is our chip. I've got 4 masts set up and I'm using just 2 ICs. The reason I'm having to use 2 integrated circuits is because of the auxiliary high and the common has to be so the LEDs have to be connected to that particular common rail. So here I've got 7400 chip number 2, and I'm using one of the gates in it, and this is chip number 2, and that's another set of gates in it. And at the top of my diagram I've got 7400 chip number 1, gate number 1, and this is gate number 2. Again, they share auxiliary low and the common low. This one uses the auxiliary high. Oops, I haven't drawn that in there. Let's quickly do that. Auxiliary high goes over there, and it comes down to the common, there we go, into there, like so. Right, okay, let's have a go and I'll show you what the outputs mean. So I'm using a Digitrax Zephyr down here. So we'll start with the first chip, which is already on red. So that's 257, so 258. And if I set that to closed, we've now got a single amber. If I then check it to thrown, I get a double amber. And then if I do 257 and set that to closed, it should go green. All the other LEDs are still on red. Okay, so let's check the next one. So 259, so 259 is already thrown, is red, so we want to go 260, set it to closed. And we're looking at this mast over here now, so there's a single amber on there. Set it to thrown, it goes double amber, and then 259, set it to closed, and then that goes green. And here we've got the other two masts, so let's try the next one, which is going to be 259. So 259 is already on red, so we do 260, set it to closed. Where have we got? We've got a single amber over there. Oh no, I've just done that one. I think I might have got myself confused. And then thrown double amber, and then we set 259, set that to closed, and that goes green. So now I've got two going green. And the next one is 261, which is already set in the thrown position, which is red. So 262, set it to closed, or give a single amber. Set it to thrown, goes double amber, and then 261, back to closed, and that one goes green. And then lastly, 263 is already at red, so 264, set it to closed, goes single amber, thrown, goes double amber, and then 263, back to closed, goes green. And it doesn't affect any of the ambers using my chip to generate that extra amber LED. So basically what it does, as I said, is it looks for when red and green both go out, effectively making it a high signal. Two highs into a Nand gate gives a low signal out, and a low signal here, and there's a high here, means electricity flows in that direction and the LED switches on. So the only thing I'll add to this is that you must have a resistive load with your LEDs. If you, even though it's only a couple of volts here, it's tempting to put just the LED without the resistor in. It does affect the logic input level of the chip, and it doesn't function properly. So these masts, that Digitrax masts that come with the SE8C, I believe have 100 ohms in line with each resistor. So it's important to make sure that resistor is in place. So anyway guys, I hope that's going to be helpful to you people. I know I've seen about 2 videos on YouTube showing 4 aspects, but they don't tell you how to do it. This is how to do it, and not using an extra switch, because I know some people, I think the way they got around it was using an extra switch, which means you lose a red and a green aspect, or another set of signals. Keeping it this way with just 2 chips per 4 masts means you can use up to 32 4 aspect signals on your layout per board. Anyway, hope that helps. See you later. Bye bye.